All right, let's start. Yesterday we discussed about threats, risk, and vulnerability. Okay, you know these terms now. What is risk? What is vulnerability? What is threat?
Yes, sir.
Now, suppose let me ask you a question before we start. Let's suppose there is a Microsoft company and they discover a problem, they discover a bug, they discover a vulnerability in Windows system. Okay, how is this vulnerability getting known, or how do people around the world refer to that exact bug? Now, for example, that bug was discovered in USA. How is other people in the world going to get to know about that particular bug?
Is it through OS?
No. How will they know is that bug which is discovered, is it dangerous or not?
Mm.
There is a database we normally use MITRE. Would
Mhm,
have almost like all the cybersecurity threats or the recent threats or whatever is going on as a global database.
mhm. That is where your CVE and CVSS comes into picture. So CV is going to tell you what that vulnerability is, and CVS is going to tell you how serious or how critical that vulnerability which is found that is. Because everyone will give a different definition to that vulnerability, right, which is found. Some will say it is normal, some will say it is very critical, some will say it is just information, it's not critical, it is harmless. So everyone will have a different definition. We need a standard purpose to see how dangerous that vulnerability is and how to refer to that particular bug all around the world. So CVE means common vulnerabilities and exposures. CVE stands for, I'll write it here, common vulnerabilities and exposures. Now, what is CVE? This is just a number, a unique number which is assigned to known
Mm.
vulnerabilities. Okay, now Microsoft discovered a vulnerability, right? So what they will do, they will name, they will give a number to that specific vulnerability. So think of that number like your security number. You have security numbers in US, right? So think of that number like a security number or like a passport number which you give it to your vulnerability. Every person will have a different security number. Every passport will have a unique identity number, right? Similarly, every known vulnerability gets a unique CVE ID. So go anywhere in the world, that ID remains the same, just like your passport. For example, your passport number is 12346, something like this. Just giving you an example. 123497. This is a passport number and it belongs to Aga, for example. So no matter where is he right now in the world, is he in Russia, India, Nepal, US, anywhere, this number uniquely identifies Aga. this passport number. Similarly, CVE is a number which is uniquely identifying that publicly known security vulnerability. Why do you think this was necessary? Giving it a number and making it unique all around the world.
People can identify with the same vulnerability everywhere. It's a
Mhm.
common vulnerability.
Right. To avoid confusions, keeping a common name or keeping a common ID. For example, if that vulnerability is discovered by Microsoft and Cisco is again discovering the same vulnerability, any other product, for example, Rapid7, CrowdStrike, maybe Qualys, Nessus, all these tools are all these different tools, maybe a burp suit, all of them are detecting these vulnerabilities and everyone is giving it a different name. For example, I'm calling it A, you are calling it B, someone is calling it C. So people will be confused here, right? What to call it. Therefore, if we all are talking about same vulnerability and nobody knows about it, to avoid this confusion, there was confusion which existed years ago that everyone is giving it a different name, that vulnerability a different name. So a standard naming system was required and that was created. That standard is now called as CVE. Okay, so suppose Microsoft discovers a vulnerability, instead of giving it different names, everyone refers to as one specific template. I'll give you an example how it looks like. CVE, then there is hyphen, then the year that it was invented or it was discovered, and specific number in front of it. This is how your CVE ID will look. So CVE means common vulnerabilities and exposures. 2024 means the year in which this CVE was assigned.
Assigned.
Not necessary that it was exploited in this year, okay? It is simply the year in which it was published. That specific vulnerability was published and reserved for this specific ID in 2024. And 12345 is like a unique number, identification number. So no two vulnerabilities will have same number. It will be unique for everyone. There can be thousands and thousands of vulnerabilities discovered in 2024, right? That is the year. 12345 is specific vulnerability. So no other vulnerability can take this 12345 number now. Why? Because it is already assigned to something. Okay. If you want a simple example, let's say there are millions of cars. Okay. So instead of saying um, a Mustang car which is parked outside a market, what we say? We say there is a red Mustang having license plate MH12AB1234. Just a number I'm giving it. So immediately everybody knows that this exact vehicle, a red Mustang, is being referred. CV works exactly like that. You're referring to that specific vulnerability globally around the world using CVE. So do you think this CV is going to tell us how dangerous that vulnerability is?
No. No.
No, right? This is a big misconception that naming it, giving it a name is one of the biggest misconception that it is going to help you identify how
The
dangerous that
severity.
vulnerability is. This is just a naming convention, right? CVE only identifies the vulnerability. It doesn't tell you whether it is critical, is it low, is it high. For that, we need
CVSS.
CVSS. So who assigns this CVE? This unique names. Who gives these unique names? This program is managed by MITRE. MI. Someone is on. Okay. Hmm. So this CVE program is managed by MITRE. It's called MITRE. Now, what is this MITRE? MITRE means this is like an organization. This is like a framework. It's a big topic. I'll try to cover it in short. Okay. It's a non-profit organization, MITRE, that works with governments, your agencies, or any companies, so that your cybersecurity posture is tightened and it's like it is developing several cybersecurity frameworks. This organization, MITRE framework, on the basis of knowledge. It's one of the most uh, famous, I would say, organizations which is used, and it refers to and this framework has one of the most important framework which is called attack framework. ATT. It's called and a CK attack framework. It's written like this. Don't get confused in this. I'll tell you. I'll simplify this. One of the most famous framework used under MITRE is attack framework. Now this attack has a full form. Okay, attack means adversaries, tactics, techniques, and common knowledge. That also I'll write. It's adversaries, sorry, it's adversarial tactics, techniques, and common knowledge. ATTACK, and is like this. So what does adversarial means? This is like a attacker or a hacker. Techniques means what is the goal of that attacker. Technique means what methods he is using to achieve that goal. And common knowledge means information that is collected by real cybersecurity attacks or something which is made publicly available. That is common knowledge. So in simple terms, this MITRE attack is collection of hacking techniques which is observed all around the world in actual cybersecurity attacks. So if you go to a website called cve dot, let me show it to you. Wait. Go to the website called cve.org. I'll paste it in chat here. Open that website and just type any common CVE ID. I'll give you a CVE ID as well. Use this CVE ID to refer. You'll get a search panel, right? Where is it? There was a search panel. Just paste that CV and search it. Have a look. This is a Oracle vulnerability. When was it published? When was it updated? What is the description of it? CVSS, I'll tell you what this is. Right now, just have a look at this. So this 35273, it was discovered in 2026. It's a Oracle vulnerability. Details of that vulnerabilities are made public so that people know about these vulnerabilities. References to it, all this information is made public. Now there are thousands and thousands of vulnerabilities. You can go on internet, find the list of vulnerabilities that are there. If you want to have any specific product, for example, this is Oracle, right? If you want to find out Cisco vulnerabilities, just go on Google, type Cisco vulnerabilities. It will give you a list of vulnerabilities that exist on Cisco. Check it out. Search in this panel. It will give you information about it. What are the references to it? How to get it patched? Everything about that vulnerability. So this is the website where people refer to it. Okay. Let's get back. Hmm. So now, what purpose is this MITRE serving, MITRE attack serving? Why was it created? Because before this attack, security teams they had problems. For example, there is a company called TCS. TCS would say the hackers were using PowerShell. Microsoft will say no, no, they were using malicious scripts. Deloitte will say they executed some commands. So all of them might describe the behavior of that attacker, but the language they use is different. So what Mitre did, Mitre created attack, ATTACK, to give it a common language. Now every organizations, every vendors, all the researchers, they all describe attack behavior in the same terminology, in the same language. So imagine if you are a security person, if you are a security analyst working in that company, and alert says PowerShell is getting executed. Is that enough to tell you that you are under attack? No. It's just PowerShell. Now imagine that you know PowerShell and it is commonly used by attackers as a scripting language, the technique used in MITRE attack. Now you can investigate this topic more effectively because MITRE is going to help you understand what that attacker is trying to do, what can happen next, what techniques can be used, how to detect them, how to stop them, all the remediation possible combinations, everything is mentioned in this MITRE attack. Okay, so there is a official MITRE ATT&CK website as well. I'm sharing it with you in chat. Check it out. See this information about attack. Look at this. This is a known topic to you. Phishing for information. You have learned about phishing, right? Open it. See. Do you know this term spear phishing? Yes, you do. So all information, how these things are conducted, what are the procedures used, what are the mitigations to it. See, user trainings and all, we have discussed about these terms, right? So explore this website in your own time. This is very interesting. I'm just going to tell you what is important here. Techniques. I'll tell you what these things are. Okay, few of the things might be also related in your second class for your red teaming, scanning and all this, vulnerability scanning, word list scannings. So check it out in your time whenever you get it. There are total 14, I believe, if I'm not wrong. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then slide it to right, left and right. Now, what are these things? Reconnaissance, resource development, initial access. These are tactics. This is one of the most important page you will see. It displays tactics columns and techniques are the rows. Now, what is tactic and what is technique? Tactic means
Goal.
goal. Okay, and technique means
How to
Methods.
Methods.
methods used. Okay, tactic means goals and technique means what method is being used. So the rows that you see, this rows, information gathering or compromise attacks, what are these things? These are techniques. And what are the goals? Reconnaissance means what? Information gathering, getting initial access, execution. Persistence means what? Staying into the system. Privilege escalation means what? Suppose you have uh, zero level permissions. You are making it to root level permissions. Privilege escalations. Credential access, password attack, brute force. You know about brute force, right? See, you can explore these categories. So the columns that you see, these are goals, these are tactics, and techniques are sorry, columns are tactics and rows are techniques. Now, for example, here reconnaissance. Reconnaissance means collect information about your target before hacking or before attacking. That is called information gathering. It's like doing research. For example, now Aga is my target. Where can I find more information about it? How can I do that? I can use LinkedIn, I can use emails, I can discover his public IP addresses. So, what techniques are used in reconnaissance? That information is given under that column. Or there is resource development. What is resource development? Things that you need to, needed for attack. For example, you're trying to cook something. Just giving you a simple example. You're trying to cook something in the kitchen. You will have to prepare the ingredients for it first, right? You will need capsicum, you'll need onions, you'll need oil, pan, gas, etc. etc. What things you need in order to perform that attack? Those things are given in this section. That is initial access. See this initial access, this column. What is it all about? How do you get into your victim's environment? Initial, how do you get that initial access? It can be through phishing, it can be through stolen credentials, USB drives, or any vulnerable web application, anything. Then you have execution. Execution means running a malicious piece of code. It can be through scripts, PowerShell, command prompt, anything. So all these categories are mentioned here. Take your time, explore this thing after the session today. Okay, try to understand this. We'll deep dive into this, or we'll discuss few points of it in the next session about MITRE framework. Okay, right now let's come back to CVE and CVSS. Let's talk about that thing.
So basically, this is like a manual for like common known attacks, right? That's how we
Yes.
can. Okay.
What steps? Now, for example, Manju is, I'll take two scenarios here. Okay. Let's say Manju is a attacker and she's not sure what to do next. She can
Mhm.
refer to this website as a manual guide, right? What to do next, how to approach.
Okay.
She can take it as a reference, something which will help her plan her next step from evil point of view. She can do that. But what if she is a analyst? What if she is a security engineer? She will use this website to plan her next defensive approach. Now Manju knows that okay, attacker has used this strategy. Should I refer to my tree to check what is the next step or what is the next course of action the attacker might do? She can refer to this thing. It's like a manual that can help you to understand what can be the next course of action or what steps the attacker is going to take. Right? Clear?
Yes. Good. Thank you.
Yeah. So in simple language, if I tell you, let's understand with an example. Let's say someone wants to rob a bank and you think that he just wakes up in the morning, walks into the bank, and steal all the money. No, this is not how it happens, right? First, he will make a plan. You have seen it in movies, right? Batman movies, or any. Everyone has seen Dhoom 2 movie, right? Anything like Mr. A and all. So it's they make a plan first, templates and all. There is a blueprint. They have maps of the building. They make plan first. They watches or they observe these bank activities for few days. They check what time your security guard is coming, what time they change their shift, where are the cameras placed, what tools he needs to buy. After that complete planning, then he will try to enter the bank. He will steal the money and then he will escape. So that there is a proper planning done. Same way, your cyber attacks are planned. They don't suddenly hack your company. Like, okay, I see a open port, let's attack it. No, they'll have to check the steps, they'll have to know the consequences. So all these things, the MITRE framework helps you with. It's like a simple reference point which is going to explain you all the common steps that attackers usually follow. That's all it is. Common steps that attackers usually follow. Now imagine there are so many robberies taken place all over the world, right? Imagine the police have spent 20-25 years studying thousands of robberies, and after studying them, they create a book. They say most of the thieves first watch the house, then they look out for an unlocked door, then they enter, they search for valuables, and then they escape. This book does not teach how to steal. Okay, instead, it helps the police understand if we know what usually thieves are doing, we can stop them before they succeed. So, MITRE attack is working in the same way. Instead of studying thieves, it studies hackers. Yeah, cyber security hackers. So what is the attacker going to do first? Then what he will do? What he will do next? How are they going to steal the data? How do they avoid getting caught? After studying thousands of attacks all over the world, they created a one big guide. That big guide is your MITRE attack framework. Clear?
Yes.
Okay. So make sure you go through this. Let's jump back to our CVE and CVSS now. Hmm, right. Now comes the second part, which is CVSS. This is known as Common Vulnerability Scoring System. CVSS. Common Vulnerability Scoring System. Now, what is this? Why was it required? Now, let's say you own a school. One day, someone walks in and they try to steal your computers that are there in your labs. Police comes for investigation and they'll ask you what happened, how the robbery took place, and everything. And you will say that there was a person who entered from the back gate. He just jumped over the wall, he entered into your campus, he stole the computers, he climbed over the wall and he stole your computers. And you all were playing in the playground or something like that. Someone will say, no, no, he entered from the terrace. He entered somewhere from the terrace gate. Someone will say, no, he entered from the window gate. Everyone will have a different story to tell. Now imagine if every school uses the same format. Instead of saying random things, everyone writes he entered from the back gate, then he went to the computer lab, he stole the computers and he escaped. Now everyone will understand that incident in the same way. You have created one template of that story and you have made it public. So MITRE attack gives a common language to describe your attacks. It's not like everyone will have a different story here. No. MITRE attack is going to make it a common story, common language to describe your attacks. Now, what part does CVSS play here? CVSS is like a industry standard to calculate the severity of your vulnerability, how dangerous that vulnerability is. That is calculated by CVSS. It is going to measure how critical or how severe that vulnerability is. Think of it like your exam marks. Every vulnerability will get a score. You have studied about vulnerability. What is vulnerability? A flaw. So is that flaw dangerous or is it less dangerous? It is going to get a score. Suppose there are two vulnerabilities, vulnerability A and vulnerability B. An attacker can completely take over your system by vulnerability A, and B is like a software vulnerability. So if you have two vulnerabilities, both of them are good enough, which vulnerability do you think will be exploited? That depends on the CVSS score. Are they both equally dangerous? No. One is dangerous, one is more dangerous. So which one is going to be critical? How do you decide that? With the help of
CVSS.
CVSS scores. That CVSS score is going to tell you the difference. Another simple example. Let's say you visit to a hospital. Patient 1 is having a mild fever and patient 2 is having a heart attack. Both are patients, right? Both are vulnerabilities. Who will get the treatment first?
Critical.
Critical one, heart attack one, right? So the doctor is assigned to that priority. CVSS does exactly the same things for your vulnerabilities. So you have a table, you have a scoring system. I'll draw that table for you. Okay. Now this number goes from 0 to 10. 0 means no risk. Skip it here. 0. You can call it no risk or information. When your score is 0, it means it is harmless. It's just an information. Then you have 0.1 to 3.9.
Mm.
This is the low category, low severity. This can be minor configuration issues or any information disclosure. It's on a low rating, 0 to 3.9. Anything which comes in this range, 0.1 to 3.9, it will be given as low rating. Okay, low CVSS score. Next one that you have is 4.0 to 6.9. This is
Medium.
medium. medium vulnerabilities. Next, 7.0 to 8.9. These are high vulnerabilities. Last one, 9.0 to 10.
Severe.
This is critical vulnerabilities.
Mm.
So critical vulnerabilities are those which require immediate attention. This can be very harmful for your organizations. So if you have a vulnerability scanner, you're going to learn about vulnerability scanners also here in the class. Okay, so in your second class you will be learning mostly about Nessus. So you will be using that tool to scan websites and then find a vulnerability. So once you find that vulnerability, you will see separate columns. There will be given a ID, there will be given a name of that vulnerability and the CVSS score for that vulnerability. Now, if there are 1,000 vulnerabilities mentioned in that report, are you going to fix them all? Do you have so much of time? Do you think organizations they have so much of time to resolve all these vulnerabilities? No. Usually, what we people do is like I'm telling it to you from my experience. We had 80,000 plus assets in our project. 80,000 plus. And all these assets had vulnerabilities on them. There were servers, there were web servers, computers, laptops. All of them had different vulnerabilities. And there was only 4 team members managing these assets.
Mm.
Now, when we scan every day new vulnerabilities are coming up. Do you think it's easy to manage all these assets, 80,000 plus assets, which are internet facing? No. We used to have schedule scans, schedule reports. What is the technique used? We focus on critical and high level vulnerabilities first. We try to patch them, reduce the score, reduce the vulnerabilities, move on to the next vulnerability. Again, medium and low. Are they not important? They are. But
Yeah,
what is the priority right now?
severe critical.
Getting this. So CVS is going to help us. We'll solve the critical first, then high, then medium, then low, if we have time. Now, imagine the same example which I refer to that same example which I gave yesterday. So there was a server which was not used for 7 years, right? So when that server was being used, let's say 7 years ago, in a month, in 2 months, in 3 months, there also existed vulnerabilities, right? But were they severe? Were they critical that time? No. Nobody updated it with time. Let's take a simple example. You have a laptop. You bought it in 2000, year 2000. There was Windows XP running on it. Okay. And since then, you haven't updated that laptop. There is no security patch implemented, nothing, nothing. Was that device vulnerable in year 2000? No. It was perfectly fine according to market standards, completely patched. But as years moved by, new security risk came up. So maybe that time that severity or that vulnerability had score low or medium. But in today's world, everybody knows about that vulnerabilities of Windows XP, Windows 7. So now those vulnerability score increased from medium to high and critical. With time, that score increased. That is what happens. So what factors decide this CVSS score? It's not any random number that you give to any vulnerability. Let's make it 10. No, no, no. I don't like number 10. Let's give it 6.5. No. It is calculated using several metrics. Let's understand those metrics one by one. First one you have is attack vector. It's called AV. Attack vector. Sorry, ATTAC. Hmm. Now what is this attack vector? Attack vector says where can an attack exploit it? What are the possible values? It can be internet, it can be network, it can be adjacent network, it can be local network, it can be physical. So there are values given to it. Network means can it be exploited over internet? Most dangerous. Internet facing vulnerabilities are most dangerous. Remote desktop vulnerabilities. For example, I'm sitting here and I'm trying to access Aga's device sitting here. What is this? I'm exploiting a remote desktop vulnerability. He has vulnerability on his device and I am exploiting it remotely over the internet. These are network based. Adjacent network means, for example, attacker is sitting on the same network. Example, your Wi-Fi. You both are connected to the same Wi-Fi. You go to a public cafe to have coffee. Both are connected to the same Wi-Fi. One is a legitimate user, another one is a hacker. That is adjacent network. So that's attack vector, AV. That is one matrix. Second thing that you have is attack complexity. It's called AC. Attack complexity. How difficult it is to exploit. Is it easy? Is it very easy? Is it very difficult? Does it require any special permissions, any conditions? That is the attack complexity. How complex it is. For example, do you know about race condition? Have you learned about race condition yet in your second class? No, not yet.
No.
Okay. With time, you will learn about a term called race condition. It's a rare configuration exploit. We'll learn about it. That time you can relate to this topic, attack complexity. So you must win that race condition or exploit in order to perform that attack. That's an complexity, attack complexity, how complex it is. Then there is third thing called PR. PR means privilege required. Does that attacker already need or does he have the account already? No. Can anyone exploit it? Depends. Is it dangerous? Is it low? Is it high? For example, uh, he needs administrator access first in order to perform that attack. So that is a high level. If he needs a normal user account to perform that attack, it is a low level. That is what privileges are required. Does that attacker already need an account to perform this? Yes or no, depending on that. You have scoring low, high. This is another matrices. And then there is user interaction. User interaction means does someone need to do something in that case? For example, you have studied about phishing. You have to deliberately click on that link, open that attachment, download that malicious file. If no user action is needed, that score is usually higher. So there are different matrices. So no need to get confused. There are multiple matrices involved in this. From interview point of view, what can be asked is CVE and CVSS. So when question comes up, I can deep dive into this topic for hours and hours, but no need to make it complicated. Let's keep it simple, easy to understand. CVSS means this is just a scoring system given to check the score of your vulnerability, how critical that vulnerability is. So it is expected that you know this table at least in CVSS. Okay, no need to worry about this AV, AC, PR, all these things. CVSS, its definition, and this scoring system. At the later part, once we complete our syllabus, I'll tell you how we manage things in vulnerability management. I have played a part in vulnerability management for years. So I'll share you my experience, something which will be useful for you, what tools, what day-to-day activities we used to perform, how we used to do it, how our team used to operate, all this, all these things, all these insights, my experience, I'll share it with you once the syllabus is completed. Okay, when your interview preparation and all will start that time. It will be very useful for you to demonstrate your experience. You can correlate with that experience and you can talk about it. So clear what is CVE, what is CVSS, both these things. Any doubts?
No. Can you repeat on the attack vector once?
Okay. Attack vector. This one. All right.
Yeah. Where that attack can exploit.
Hmm. Now attack vector means think of this like a path or a route that attackers they take to launch their attack. A way in which that attacker is going to launch its attack. For example, if attacker wants to break into your company, first question is how is that attacker going to get into my company? The answer is attack vector. Let's say someone wants to steal money from your house. There are many ways to get inside your house, right? It can be through front door, through windows, climbing over the wall, or pretending to be a delivery person, anything. But what is the goal entering into the house? So thief here has only one goal, entering into the house. But there are multiple ways that he can do it. Those different ways are called as attack vectors. Possibilities, in short. If I give you a one word definition, call it possibilities in which that attacker can perform that attack. If you want a bookish definition, it's like an attack vector is something like a path or a method that is used by an attacker to reach or to exploit the system. It is a bookish definition. You call it possibilities. Simple. A route which is taken by attacker to launch that attack.
Got it.
Clear?
Yeah. Yeah.
Okay. That is why we discussed about network, adjacent networks, and all these things, right? Can it be done over the internet? Can it be done through Wi-Fi, adjacent network? Any doubts in CVE, CVSS? Let me know. All right. Now let's jump on to few questions just to understand if you are comfortable with the topic. Okay. Can you tell me what is CVE? Just the full form.
Common
Common
vulnerability
vulnerability.
exposure and
Exposure.
exploit.
Okay. What is the purpose of CVSS?
Uh, to rank, I mean, it's
The
helps
severity of
calculate the severity of vulnerability.
vulnerability.
To measure or to count the severity of your vulnerability.
Vulnerability.
Which one of the following gives you a unique ID? CVSS or CVE?
CV,
CV.
CVE. Okay. Which one tells you how dangerous that vulnerability is?
CVSS.
CVSS,
CVSS. Which one helps you identify a vulnerability?
CVE.
CVE.
CVE. Okay. Does every vulnerability have a unique CVE ID?
Yeah.
Yes.
Are you sure?
Yeah.
Yes.
Yes.
Alright. Publicly disclosed vulnerabilities generally they have a unique ID.
Mhm.
Can two different vulnerabilities have same CVE number?
No.
no,
No. Can CVE number or can CVE ID tell us whether that vulnerability is critical or low?
No.
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 Yes.
No. Who said yes? No.
Everybody said no.
What is the highest CVSS score that you get?
10.
10,
10. If the vulnerability score that you get is 9.5,
Critical.
Critical.
should that be fixed immediately or later?
Yes.
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 Okay.
Anything under critical should be taken care.
Right. Now, since this topic is clear now, since we have time 10-15 minutes, let me cover a simple thing which is related to this part, which plays an important role. We'll talk about SLA.
Hmm. A quick short question. If we have
Just,
vulnerabilities like 10, 9
mhm,
are high, 1 is critical.
mhm.
Still, we have to take care of critical first.
Sorry, can you repeat again? 9
We
is?
have 10 vulnerabilities,
Okay. Mm-hmm.
and they're out of 10, 9 are high
Mm-hmm.
and only 1 is critical. So
Hmm.
still our first focus should be critical, right?
Yes. Yes, definitely. Therefore, you have that scoring system, right?
Right.
Simple question. Let's say there are 10 people and I scored 10 marks. You scored 9 marks. Who's going to be rank 1?
10,
Me, of course, right? I am scoring 10 marks, 10 out of 10. So I will be rank 1.
same thing.
Can so this is scoring system, therefore it is used. Now the trick question here is for those 9 high vulnerabilities which you mentioned, which one will you tackle first? That depends on the exposure of that vulnerability.
Mm.
Right? Your question was good. Like, should I go for critical or should I go for high? Of course,
Right.
you should go for critical, but once that
Critical.
critical one is patched, once
Right.
that is fixed, what
Mm.
about the rest 9 high vulnerabilities that you have?
Mm.
Which one are you going to choose first?
Well,
That
like
depends
you
on
want
the
to say that if it
exposure.
is one is 7.5, 7.8, 8.5, 8.9, you go with the highest one, 8.9. That's how you want to ask.
That is
Mm.
one thing you can do. But
Do.
what if one is internal server and one is external server? Now, for
Oh.
example, you have two vulnerabilities.
Mm-hmm.
Okay, understand this question properly. You have two vulnerabilities with same score,
Mm-hmm.
7.5.
Right.
Which one are you going to patch first? One vulnerability is on your internal server and one vulnerability is on your external server or internet facing server. So that depends on
Internal.
the exposure. Yes. So you'll face the internet
Internal.
facing first. That time you have to check exposure of that, how critical that vulnerability is, who are the asset owners. For
Mhm.
example, if it is a CEO's asset, right, there can be more possibilities. If it is a normal employee with low privileges,
No problem.
yeah, you can do it later on, but you will have to do it since it is a high vulnerability.
Mhm. Thank you.
Yeah. Let's talk about SLA. SLA means service level agreement. When you start working, I don't know if you have heard of this term.
Yes, I have heard about it.
So many times. I don't know where.
For those who are working, they might be familiar with this term service level agreement. But for those who have non-technical background, this might be a new concept for you. Now, what is SLA? SLA is like an agreement that is defining how quickly a service should be delivered.
Mm.
Now, usually in companies, when you are playing a cyber security role, this term is going to be always in front of you. How quickly a task should be completed.
Mm.
Now, if you have a vulnerability having score 10, and let's say you're working on it, how long are you going to work on it? Years, 2 years, 4 years, 5 years? Till that time that attacker will exploit and go back, he'll sleep. You don't have enough time. How many days does a team have to fix a vulnerability? That is what is SLA. There is an agreement between you and your customers, your stakeholders. For example, let's say you order something on uh, Uber Eats, right? You have Uber Eats in US. You order something on Uber Eats and it shows delivery time as 30 minutes. So that 30 minutes, that Domino's pizza 30 minutes, that is a commitment. It is a SLA. What happens if that SLA is not met? You get that pizza for free, right?
Yes.
That SLA is breached. Who's at loss here?
Company.
Company. So in cybersecurity, if your company is performing a vulnerability scan and that scan finds 10 vulnerabilities are critical, 25 of them are high, can the IT team fix all of them in a single day? No. Company will create a SLA for them. Like let's give maximum 7 days to solve the critical vulnerabilities. Then we can fix high vulnerabilities in 15 days,
Mm.
medium in 30 days, low in 90 days. So you can divide that task properly and everybody knows their deadlines that okay, I have 7 days to fix this seven whatever 10 vulnerabilities, 10 critical vulnerabilities were there. After 7 days, that SLA will be breached. And what will happen if this SLA is not into picture? Without SLA, teams will keep on delaying the vulnerability fixes. We have this habit. There is that saying, "Aaj kare, kal kare so aaj kare so ab" kind of things. You have heard this, right? You have to give a specific timeline to resolve those vulnerabilities, or else we will just keep on pushing this task to someone else. Those vulnerabilities will never be fixed. It's an agreement between you and the customers. Security team will say we will we have find the vulnerability, fix it. IT team will say we'll do it later. 1 week passes, another week passes, month passes. Nobody knows when it should be fixed. So SLA is going to remove this confusion by setting a clear deadline. And when the things are not completed within the agreed time, it's called SLA breach. Breaching that SLA. And who's going to decide this SLA? It depends on your business requirements. Whatever compliance requirements you have, whatever internal security policies that you set, based on that, some companies will say we fix critical vulnerabilities in 7 days. Some of them will say we need maximum 2 days. Some will say 3 days. It depends on your business requirements, compliance, security policies. So
But
typical on a rough scale, I'll say critical will need 7 days, high will need 15 days, medium will need 30 days, and low will require 90 days. You fix those vulnerabilities in this given time frame. This is a standard template. It differs from company to company business requirements. It's not universal, it's not standard. Okay, I'm just giving you a rough template. Don't get confused between SLA and priority. Both are two different things. Priorities means which vulnerabilities should be fixed first, and SLA
Yes.
means by when it must be fixed. There is a difference between them. It's a timeline. SL is a timeline. Priority means which one to take first, which one to work on first. Clear?
Yes.
Any questions on SLA? You know that companies they do billing, right? If they are giving you this security project to handle, they look into this scores later on. What SLA was breached, how much, because it's an agreement between you and customers, right? So if you're breaching that SLA, is customer going to agree on that part? If you order food and that food is served cold to you after 2 days, will you agree to it? Of course not, right? So customers, and now once this agreement is broken or this SLA is breached, it's not that customers they immediately back out. No, they'll give you chances. They'll ask for improvements. And these things are still taking place. There comes a point that projects are rolled out of the company. Those things are handled too. I'll tell you a real case scenario. I used to work for a company, XYZ company, and that company had a project where we had Australian clients. We had a team of 20 members and everything was going well. But later on with time, some of the members they switched, they changed, and no new hiring was done. Initially, we had 20 members, but later came a point that only 8 members are handling the load of 20 people. What would have happened? SLA was getting breached time and again. We couldn't manage that workload. We couldn't handle that project. Customers, they kept on complaining, things they kept on getting worse, vulnerabilities, they kept on increasing. The last point was customers, they decided to take this project from that XYZ company and give it to some other vendors, maybe ABC or some other. So they rolled out the project from that XYZ company. These are real case scenarios that happens. What customers are expecting, if I am paying, I will need the service, right? So it's a critical factor, SLA. And one more thing, this is a new term for you. It's called aging report. I'll refer to this term later on again. Aging report. There is a report in which it says how many vulnerabilities are not fixed. Now, for example, we had 10 critical vulnerabilities. It was supposed to get fixed in 7 days, right? But it's going on 14 days, 20 days, 25 days, because fixing a vulnerability can be a task. It's not that always you look into a vulnerability and it's immediately patched. No, there are so many factors affecting that patching. For example, if a guy is working in the application team who's looking after patching and he's on leave for 4 weeks, I send that ticket to their team and no one is available to patch it. Is that SLA going to breach? Yes, of course, because no one is there to patch that vulnerability. It's affecting my patching, my work. In that case, that vulnerability goes in aging. You have to send reports to your stakeholders, your customers every week about what is the progress, how things are going. So that time that vulnerability goes into the aging thing. How old that vulnerability is. Companies, they have vulnerabilities existing from 5 years, 7 years, 10 years. So they just keep a count of these vulnerabilities in aging report. Because they have to keep a track of everything. You have to discuss things with customers every week. We do have client meetings every week discussing about these vulnerabilities. So is it a good practice to reduce the aging numbers? Yes. Okay. So that's all for today. You have learned about SLA, aging, CVSS, CVE. Please make sure you go through that MITRE page properly. Look at the columns, look at the rows, see what tactics, what techniques are. Go through it, look at those procedures that are followed, explore it. Okay.